Okay, doke. Here's the deal with implicit differentiation. Okay? Usually we have so far in calculus had an equation that solved for y, right? Or at least it looked like it was solved for y. Y equals or f of x equals or something of that nature, right? It's been something equals and then we have an equation that comes after that. Okay, which is wonderful. If we can solve the equation for y and isolate the variable, it makes the derivative taking a lot easier. Okay, but sometimes it's not so easy to solve the equation for y. Like this one right here, y cubed plus y squared minus 5y minus x squared equals negative 4. Okay, that's a pretty hard one to solve for y. So rather than solving this for y and then taking the derivative, we're going to do what's called implicit differentiation. So we're going to take the derivative with respect to x. Okay, which means that if there is an x in your problem, right, like this 2x squared, we're going to take the derivative of that like you normally do, right? Nothing changes when we have an x involved. But when there's not an x involved, like anytime we have just a y, so taking the derivative of a y thing, we're going to do just like we do for an x. Okay, so like the derivative of y squared is 2y to the first power, but then we're going to multiply it by this dy dx. Okay, and sometimes, actually oftentimes, I'm going to call this y prime, right? The derivative of y. So you can use either notation, dy dx, or you can use y prime. Just know that in most cases, the problem is going to ask you to find dy dx, okay, not y prime. But y prime is kind of the lazy way of writing dy dx, but it means the same thing, the derivative of y with respect to x. Okay, so let's just jump right in here and see how this works. Okay, so we're going to take the derivative of this equation of x squared plus y squared equals 0 with respect to x. Okay, so what is the derivative of x squared? Well, that's just 2x. That one's pretty good. Plus the derivative of y squared with respect to x. So notice there's not an x term involved. But what's the derivative of y squared? That's 2y. But because we took the derivative and there's no x, we have to add this y prime or this dy dx. And of course, the derivative of a constant is still 0, so that's still 0 on this side. Okay, so that's the first part, taking the derivative, right, correctly. So every time we take the derivative of a y, we're going to have a y prime or a dy dx. Okay, so our next part is to solve for dy dx. Isolate this variable. Okay, so in other words, get y prime by itself. It says solve for dy dx, right? That's our last step. Solve for dy dx. So our first step would be to subtract this 2x to the right side, right? We want to isolate y prime, which means get y prime by itself. So 2y times y prime equals negative 2. Sorry, that should be an x over here, not a y. Sorry, this needs to be an x. And then our last step would be to divide by 2y. Okay, so we're going to do some simplifying. 2 divided by 2, that's a pretty easy thing to simplify. So y prime is the negative of x over y. Okay, so we can find the slope of any point on our curve by taking the negative of the x value and dividing it by the y value. And of course, that's our job later, is to write an equation of a tangent line. And for a tangent line, we need to know the slope. So this is the slope of any point on our curve if you know the x comma y. Just plug it into here, and that's going to be your slope. Okay? So not too bad, at least to start with. Right, of course they get much worse, but we'll do it slowly and easily to get you in the groove. All right, try the derivative of this one. So we take derivative of x squared, like we've always done, plus now the derivative of 4y squared. Okay, like we usually do. So 2 times 4 is 8y times y prime, or dy dx, equals the derivative of the constant, which is 0. So the derivative of our constant always remains 0. Okay, so now our job is to solve this for y prime. Okay, so what we're going to do is move the 2x to this side, so it becomes a negative 2x. And then we're going to divide both sides by 8y. Okay, so get rid of this stuff. So when we simplify, we get y prime, or dy dx, equals negative x over 4y. Okay, so in this case, we can find the slope of any point, right? This means slope of any point by making the negative of the x coordinate divided by 4 times the y coordinate. Okay, so we're still finding slopes. So that's the whole point of derivatives, is to find the slope of the line tangent to any point on your curve. So remember, that's still our goal when we're finding a derivative, is to find the slope of the tangent line. Okay, so here are some more examples of taking derivatives, just straight up derivatives. So we're going to treat this like we usually do for an x. So we're going to bring the 3 to the front. So 3y to the second power is always one less. But then we always multiply it by dy dx, or y prime. Okay, so that's the derivative of y cubed. Okay, similar thing for number 2. We're going to take the derivative of x, which is just 1, plus, we do the same power rule here with our y, 8y to the first power, but we always multiply it by dy dx, or y prime. Okay, writing it like this just gets you in the habit of writing it in a derivative form for when we do related rates down the future. Okay, but if you want to call it y prime, you can call it y prime, and that's just fine. All right, number 3. Okay, what type of a rule are we going to use here on number 3? This is a product rule derivative. Excellent job, you guys. Product rule. So this is, in essence, x squared. So let's do this. Whenever we have a constant, pull the constant out and just take the derivative of your variables, your x squared times y cubed. Okay, so do this. Pull the 3 out, and then we'll take the derivative of x squared y cubed using the product rule. Okay, and then at last we'll multiply everything back in by 3, right? We'll redistribute the 3 into it to get our final answer. Okay, so we're going to use the product rule on x squared y cubed. So the product rule says we do f times g prime plus f prime times g. Or you can flip those around and do f prime g plus f g prime. Right, you take the derivative of one thing and multiply it by the other left alone, and you take the derivative of the other, multiply it by the first. So let's do it that way. So we have x squared, right? That's going to be our constant term, times what's the derivative of y cubed? 3y squared times dy dx. Okay, so that's the derivative of x squared y cubed. Okay, so x squared stays the same, and we take the derivative of y cubed. And now we're going to take the derivative of x squared. So what's the derivative of x squared? 2x. and we multiply that by y cubed, right? So we don't mess with the second one that time. So there is your product rule derivative. Okay? So now let's multiply the 3 back in. So you're going to multiply the first terms by 3, and we're going to multiply the second terms by 3. Okay, so our final derivative is 3 times 3 is 9, 9x squared y squared times dy dx plus 3 times 2 is 6xy cubed. Okay, so you're going to need to recognize when to use the product rule. If I see students make mistakes on this, it's they don't do the product rule when you have an x times a y together. Okay, our next one here, this is a fraction, so we're going to apply the quotient rule. Okay, low d high minus high d low over low low. So our low term is what? 2y to the fourth, right? So that's our term. We have not taken the derivative of it. We're just writing it down. So the low term times the derivative of the high term. What's the derivative of x cubed? 3x squared, beautiful. Minus the high term, which is x cubed, times the derivative of the low term. So what's the derivative of 2y to the fourth? 8y cubed times dy dx. Okay, because we took the derivative of a y variable, we do the dy dx. And then in our denominator we have 2y to the fourth raised to the second power. Okay, now if this were a free response question on the AP test, you would be done. That's all you have to do is take the derivative. You do not have to simplify on a free response question. Now, if this were multiple choice, they would expect you to combine your terms and do that. So let's practice our combining terms. I have a 2 times a 3, right? In this first, 2 times 3 is 6. And then I have x squared y to the fourth. Okay, so that's what I get when I simplify these terms. I multiply my 2 times my 3. Okay, and then these terms, notice there's no common multipliers. So I'm simply going to write everything down next to each other. 8x cubed y cubed times dy dx. All over. So remember what it means to square something. That means multiply it by itself. So 2y to the fourth times 2y to the fourth is 4y to the 8th power. Okay, 2 times 2 is 4, and then 4 plus 4 in your powers is 8. So that would be your final answer on a multiple choice portion of your test. You have to see it like that. Okay, let's do our last one. So here we have a square root. Okay, if you have not memorized your square root derivative, we can always change it back into a fractional power. Okay, so remember the square root becomes the 1/2 power. The square root part gives you a 2 in your denominator, and because this is y cubed, it becomes y to the 3/2 power. Okay, so we haven't taken a derivative yet. We've just changed our radical into a fractional power. Okay, changed our radical into a fractional power. So now we're going to use our power rule, which says bring our denominator to the front. So 3/2 times y to the, what is 3/2 minus 1 power? 1/2. So our new power is 1/2, and we have to multiply this by dy dx, right? Because we took the derivative of y, we need to have a dy dx in there. Okay, so we have, let's change our fractional power back into a square roots. So the 1/2 power becomes our square roots. We have a 3 in the numerator, and we have a 2 in the denominator, so all of that's going to be over 2. Okay, 3 times the square root of y over 2. And then we're going to put our dy dx up here on top. dy dx in our numerator also. Okay, so there we go. Taking derivatives with respect to x, even when we have a y variable. Okay, it's done like that. Okay, good job. Well done. Always remember there's a dy dx whenever we're taking the derivative with respect to x of just a y term. Have a great day.